Question number 10, that's from motion in a plane, kinematics. All right, let's see what does it say. A particle which is at origin starts with an initial velocity 5 meters per second along y, and it's also subjected to an acceleration this much. After a certain time, when it reaches this coordinate 20, y naught, we need to calculate the value of that time and the corresponding value of y naught. So what we do is that let's first start with a figure, because that's going to give us the nice view. All right, the particle starts from origin. That's fine, it starts from here. And the initial velocity, that is 5 j cap. So that is going to be the initial velocity. So let me write that as 5 meter per second. That's done. But then it also has an acceleration, and that's 10 I cap plus 4 j cap. So let me represent that, the acceleration. So here is 10 I cap and here is 4 j cap. So these are all the acceleration. So 10 meter per second square and 4 meter per second square. Now after a certain time, the coordinate is 20 y naught. So somewhere it reaches, we need to calculate that thing. So the final coordinate is 20, y naught. Let's begin. You know, if you see, if you talk about the y-axis, the y naught is unknown. And if you talk about the x-axis, if you see, the position 20 is there, the acceleration is also there. So if I start with x, I will get how much is the x displacement? 20, right, equals to 1/2 acceleration, that's 10 into t square. So the value of time comes out to be 2 seconds, right? So once the time is 2 seconds, that means option 1 and 3 would be eliminated. Now we just need to talk about the y coordinate. If you see along y, the value of y naught will be the initial velocity, that's 5 multiplied by 2. I'm using ut plus half at square, reason being obvious because it's accelerated, and acceleration along y is 4 into 2 square. So that's 8 plus 10, 18. So time is 2 seconds and the y coordinate is 18. Therefore, option number 4 would be the correct one. Proceeding further. Question number 11, that's from electrostatics. And in this configuration, minus q and 4q, these are the charges at distances d by 2 each from origin. And in the picture, there is another charge, that's q. Initially it was here, and it has been taken to this point, which is at a distance d from the origin, and via this path. The path doesn't matter though. Now we need to comment on the energy of this particular charge, and let's see, it's essentially talking about the change in energy, whether it's decreasing, increasing. Whose energy? The energy of this q. No question can be so straightforward than this. The initial potential energy of this q will be kq into 4q divided by d by 2, that's the first one, and with this, that's going to be minus of kq square divided by d by 2. That's the initial potential energy. What about the final potential energy? Now with that q here, it will interact with 4q, and now 4kq square, and the distance will be 3d by 2, isn't it? D plus d by 2. And together the interaction with this as well, that's going to be minus of kq square upon d by 2. Now all we require is that if I do the final energy minus of initial energy, so depending upon that I can find whether increases or decreases. We find the energy will decrease by this amount. Not to forget small k, that's 1 by 4 pi epsilon naught. The next one, and here it's a straightforward theoretical question, but that sequence of electromagnetic wave spectrum has to be memorized. So what does it say? We need to just compare the wavelength of all these things. And one small idea can help you, like starting with G, X, U, V, M, R. Now, I don't know what sort of mnemonics are you going to make, but this is how it goes in the increasing order of wavelength and decreasing order of energy. Gamma, X, ultraviolet, visible, right? And micro, radio, this is how it goes. Now, how is the parameter to be chosen? That's now so straightforward. Option number 3 is the correct one. Let's go for the next question.